And welcome to This Late Data.
Hey everybody, it's the crow to see you again. This is, I guess, the gothiest of fritzing videos where we're going to go through and make some more fritzing parts using the new Eagle to Fritzing toolset that Phil B has cobbled together. So that's exciting. We kind of did a little bit yesterday, and that was good. We made a simple part. I thought today we'd make a more complicated part. What do you think about that, Mr. Lady Ada?
Yeah, I think it's fine.
Okay.
Got a crow.
Yeah, apparently you do. Very fashionable.
Yeah, this is a special crow.
Is your little friend?
Yeah, this is a special one. And the crow is going to help us do electronics because we're talking about feather and more.
That's right. It's a feather-themed fritzing.
Yeah.
And the feathers are black, much like the inky.
Yeah. And so this is a
quills.
little crow. Okay. This is what happens.
Okay, anyways. All right, you want to go to the computer? We can show off this tutorial.
Let's go to the computer.
So I just finished publishing the tutorial that you can follow along with. It's how to use Eagle to Fritzing, a tool made by the Fritzing organization. We did a little bit of hacking, modification, compiling, noodling to make it so that you can generate pretty much automatically from the Eagle CAD file this kind of beautiful rendered, flattened, but still one-to-one perfect representation of the board that you're using. So this is like one of the most complicated boards we did. I did this kind of yesterday. Phil B cleaned up a lot of it, and we put in the silk screen as a separate file, so it wasn't a gigabyte. But this is the kind of complexity that we're doing. And in this tutorial, we show how to make, I think, the DRV 2605. Just showing how to make a little breakout. And that's all well and good. I did a bunch of these, but and you can, of course, read this tutorial, which has all sorts of fun stuff like installing Qt. But today I thought I would work on some feathers because we did the feather Ada loggers earlier this weekend, and then today I almost done with the feather Huzzah and the feather M0 Wi-Fi. So that's really good because those are very popular. But the blue fruits are also very popular, so I thought these would be great for today. So I thought, show how to do that. It's a little bit more complicated and has a little bit more of the advanced schematic editing because I like to make the schematic line up perfectly with the PCB.
Yeah.
Sounds good?
It's a big deal when the application icon ends up in your taskbar.
What, this?
Screen? Yeah.
Yeah, because I was constantly opening fritzing. It'll go away soon.
I don't. What is that time period called? Because this happens to me a lot, where I'm using an app and I'm just like, I should probably just put it like right where I would just click it instead of like going. What is that time period between using an app so much that you realize that it would be just easier to move it on the home screen or on your taskbar? Because it's like usually like days.
Yeah, this was actually within an hour because I was constantly
you skip
opening
ahead.
it. Because every time I generate a fritzing part, I have to open the app 3 times.
Okay. So you're one of the people that's just like, I'm just going to put the app there.
There's a lot of caching done, yeah.
You've learned your lesson. Mm-hmm. You're not. I'm not going to keep.
Yeah, until I have somebody else helping me with these parts, I'll probably keep doing it.
Yeah.
Okay.
You have paint. You use paint.
Yeah, I have paint.
Right.
Okay.
You want to do this? You want to generate this?
So let's do this thing.
Okay.
All right. So this is the file, and then on the overhead, I can just show what it looks like.
Oh yeah.
Really easily. So this is the a prototype, but it's the feather about 2 inches by 0.9 inches. Has a ton of components. This one I think is the this is the ATSAM D21, the Cortex M0, and then there's of course another Cortex M0, and here's the Nordic NRF51822 inside of this module. It's a lovely little FCC certified module. It's kind of handy. And here is the 32U4 version, which I put headers on. But we'll be making both of these today, and they'll be they'll be black, not the prototype colors, which is purple and green. Okay, let's go to the compy. Okay, so there's a lot of folders we have to open, and I think I have a couple of them open already. First off, let's grab the Bluefruit PCB itself. So we'll need the board file, so I'm going to grab this, and I'm going to put it in my, so I was doing the Huzzah, I'll put it in my BRDs folder, and then it doesn't like spaces. So replace all the spaces with underscore. And then I don't need the rev code because it doesn't matter. And then I already have the command line, and I run run.py, which actually does the, basically does all the management for me, opens up Eagle and exports the XML file. Looks like it found most parts. Let's see how it's looking. So I'm going to close this out, and then I'll open up the bar to SFG, Fritzing, parts, SVG, contrib, breadboard, and look at this SVG. This is the breadboard view, so this is like the kind of the most complicated one because you have to get all the subparts to show up. So the good news is we've got most of the subparts in here. In fact, it even got the QFN for the chip because I've been doing a couple other 32E4 based things. Looks like a little bit of silkscreen, just needs noodling. And of course it needs the Bluefruit module. You have to draw that as a component because it doesn't know about that. So, is there a crow issue?
No, there's nothing going on
Okay,
here.
nothing
Just
going
you
on.
keep doing engineering.
Okay, I'm doing engineering. Okay, so we're gonna get this file. So here's the deal. I don't wanna draw this because I'm lazy. So what I'm gonna do is I'm going to grab the part from Pig Hicks because he drew it for me and everything got moved around when we changed resolution. Here it is. So 2795, maybe? See if that's the part number. No, that's the micro. It's 2995. Okay, and there you go. This is, oh, sorry, I already edited this from the file. So I'll just redo it to show how I extract the SVG. So because it's all vector, you know, you can just take the file, ungroup, whoa, and then just start deleting out parts. Hold on, there's like 5,000 components. You can just delete everything, you know, when you go through deleting all the parts until you extract the component. And there's just like, you know, he generates it from the EagleCAD file, and I guess he actually grabs every trace, which is lovely, but means there's a lot of stuff to delete. Delete, delete. Actually, you know what? That was already grouped, so that's kind of convenient. So yeah, here you go, and then you can ungroup this, and then actually, I shouldn't even have to. But yeah, there's your part. So you can group it, and rotate it so it lines up. Anyways, when you're done, you have something like this. I even removed the little pads around it. So this is the finished SVG, and I'm going to save this as MDBT40. That's the name of the module. And what's really nice is like he put in like all this text in the FCC ID, so it's like really fancy. And he releases it under Creative Commons, which is lovely. So then under board to SVG, under Eagle to Fritzing subparts, yeah, I already put the file there because I was planning on doing this. So, you know, copied over, and then you have this along with all the other components you need. So there's your lovely subpart. So what we have to do now is tell Fritzing that BLE module RATEC underscore MBDT is the same as MDBT. I could rename this to be the exact part, but it's good to practice aliasing. So inside of this, under and then all packages.txt, is this like long XML document that lets you map components around. So for example, you know, we have one drawing of the Atwing 1500, and whenever you see these different parts, whatever they're called, we map it. So let's, we'll just grab this one. And then the name of the part that it is, supposed to be called is MBDT40. And then the part it's looking for is this one. So grab that. That's it. Pretty easy. And then when we run it, it will say that, oh, I didn't find it. Did I get this wrong? Let's get this backwards. No, one second. Is it MDBT? Yeah, I get that wrong a lot. We run. Go, 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 you can find it. Yes, this time it found it. Can't highlight, but there you go. Found subpart. So when we revert, you can see the part. So the thing is, it's a little too big because it's not scaled properly. So let's rescale it to be the right size, because I forgot about that. So let's open up this file. Because like Pancakes doesn't draw to scale. He just draws to like make these beautiful diagrams, and they're really beautiful, but they're not one-to-one scaling, which is okay. We will just rescale it. So if you open up document properties, you can set the dimensional for units to be millimeters. That usually makes things a little bit easier. And then let's see if I can find the MDT. I have it somewhere. There you go. And then if you look in the data sheet, usually near the end, but sometimes at the very beginning, they will have the dimensions. So it is 10 by 18. 10 millimeters here, 18 millimeters here. Super easy. So let's redo this. This is going to be 10 millimeters wide by 18 millimeters tall, about half the size. Don't forget that has to be grouped. And then in the document properties, you can do this really nice thing where you just say resize the page, and it will automatically give you the right bounding box. Okay, so let's rerun. And reload. Okay, this time it got much, much closer. It's not perfect. Usually have to do a little bit of editing, so let's do that little bit of editing. So, looks like why is there like an extra pad here? It's a little bit weird. I think he just drew an extra pad by accident. Okay, not a problem. We'll just take that pad out. I think it just wasn't. It was just a mistake. Let's see if we can remove it. I don't know if I can. Oh boy. Probably my best bet is to try to draw over it, maybe? Oh yeah, this is gonna be fun. So I have to properties. Oh, sorry, 1 second. Fill stroke. Hold on. There you go. So no stroke. And then, yeah, fill. Not you fill, but. And then maybe I can do a pickup. Nope. Okay, so this is 160, 3140, 60, 31, 40. Good as new. Nobody can even tell. Okay, let's rerun the tool. And revert. And then we can kind of shift this over. The reason it's never going to be quite perfect, especially with these modules, is because the pickup point is not always the centroid, but like it tries to guess, you know, based on the centroid, like where the part is. So there you go. That's like almost perfect. Okay, and then let's just clean up a couple other things, like this. This little this little part here. I don't know why. Got put in the wrong location. And I think that's pretty good. Then of course the background color of the PCB should be black. Yeah, no talking. And then, oops. Group that. And then we're gonna resize the page to this content. I don't know why, for the feathers, it makes them a little bit big. I think it's something in like one of the PCB layers. Okay, sweet. Oh, you know what, I'm gonna clean this up too. Just put this text a little bit higher so it's a little bit more readable. I think it's good. What do you think, Phil? Looking good?
Yeah, I think a lot of kids are going to be disappointed when they figure out that this is the new Minecraft.
Yes.
This is it. This is it.
I know, right?
The whole point of Minecraft is to go in and clean up our board files when you import them into Inkscape, Fritzing, whatever. That's the new Minecraft.
I know, it is a little bit of a video game.
Yeah. It's like Tron. You're helping the users, kids.
Yeah.
Cool.
All right, I think I'm done messing with this. Okay, so you basically clean it up however you want to clean it. And then when you're done, what I like to do is, because the tool will overwrite file changes, I go back to that parts SVG, sorry, the breadboard, and I make a copy. Because it's going to get overwritten if like the next thing doesn't work out. Okay, so let's go to the PCB next. I know that's going to be close, but not quite also. And this is in white, so it's a little bit hard to see. So you can either just make this black, or you can, in background color here, make this non-white, and so you can see the outline. And this doesn't have the mounting holes, which I would like to have appear. So what I'm going to do is, you can kind of force the Eagle to Fritzing tool to take the parts and add connections that it normally doesn't detect as connections by editing the parameters. So let's edit the parameters. And the parameters is the XML document that basically tells Fritzing like what every component is, what is the name of the pin, whether it appears or not. And this is the XML group called unused. So these are all the connections that aren't used, and these are because they're connections, but they're made to like resistors and capacitors, they're not made to header parts. All these header parts that are like JP1, these get brought out and are taken out and brought into the schematic. But we're gonna take some of the unused parts out and make them not unused. So these 4 mounting hole 2.5 millimeter plated, we're gonna take those out, and we're gonna create a new group above unused called mounting hole. It can be called anything, but this basically says it's not unused, I want them to be rendered and I want them to exist. So then when we rerun the tool, you get to run the tool a lot. Okay, we're done editing this. And then we reopen the PCB file. This time, it gets all the mounting holes. So see, like these 4 mounting holes were not there before, but they are now. So one thing I'm gonna do is, there's also like this extra space for some reason. I'm not sure why. I just resized the page, and it makes it like nice and clean. Now it's perfectly sized. And here you go, you can see like exactly the PCB, and there's an outline and everything, so it's lovely. So let me just change the background color. Actually, change it to, can I undo that? try opening it again. I'll figure out how to undo that. Okay, let's Control-Shift-D, resize. Okay, so now that I have all the mounting holes everywhere, which is nice. They'll appear in the PCB and you have all the pads. You can also make a copy of that, because again, it gets rewritten. And then finally, we're going to go to the schematic. The schematic is the one that usually you don't mess with, but I'm kind of crazy, so I'm going to mess with it. So this is what the schematic looks like, and the Fritzing creator tries to do its best to basically put all the pads in alphabetical order, and then put the power pins up top and the ground pins on the bottom.
The creator is kind. The creator gives.
The creator does its best, the best it can. But I'm actually a little picky. What I would really like is if the feather blue fruit, if it looked like if all the pins lined up in the schematic, the way they line up here, like all of these pins on one side and all of these pins on the other side, because I think that would make it easy to make diagrams if you're using the schematic view. Does Mr. Crow have anything to say? Hi, Mr. Crow. Here, I'm going to pat Mr. Crow's head. Okay. Thank you. And then to do that, you can also edit the parameters file. And what's nice is the parameters file actually doesn't get rewritten, so you can edit this and then rerun the tools many times as you want. So you can tell what it's trying to do. So up here, there's the power group, and this has all the connectors for the power from left to right. And then this is the ground group, and it has the one ground, and it has that signal here too. And then this is top to bottom, so you can see it's like 0, 1, 2, 3, 4 through A0, and these are those pins. So all I want to do is rearrange all of these to be the order I like. So we'll start with reset 3-volt AREF ground. So then I have to pick apart this XML. Reset 3 volts AREF ground, and then A0 through A5. Oops. And we'll pick out A0 from here. And then S clock MOSI MISO. So S clock, MOSI, MISO is in the right order. Just move that over here. 0, 1 DFU. 0, 1, and then DFU. Okay, and then we'll do the right side, also starting from the top. VBAT enable USB. So take those out of the power group. And then VBAT, enable VUSB, and then 1312, basically numerical order, which is exactly the opposite order that it's in, because that's how it goes. And then I only do this for the feathers, but I kind of like having all the pins in the right order. I think if I'm going to generate these, I want to generate them once. Okay, most of electrical engineering is editing XML files. It's true.
I've kind of determined most everything is editing XML files.
Pretty much your life is just editing XML. Okay, so this is the previous schematic. So you see the power pins and then 0 through 13, A0, and then it wraps around to S clock. But now when we revert to reload it, now you see it shows up in this order. Reset, power, AREF to DFU, and then 2 through 13, and then battery. So that's kind of nice. It's exactly in the right order. But I'm even pickier. I want them to be kind of lined up properly. So I'm going to ungroup, and then put the default units into inches, because unlike everything else, this one is done in inches. And then move this down like that. So now it even has the same kind of, this spot here, which is taken by the battery, is empty. So this is like a skeuomorphic-y, whatever. it's more aligned to what the feather actually looks like. So that's the schematic. Okay, great. So now we've generated all 3 piece by piece. I'm going to make a backup of this because it's always wise. And then the PCB got redone, so I got to, it gets automatically generated. So I'm going to copy this over. And then the breadboard is also regenerated, so I have to copy this over. So now all those parts are done. Whew. So now I can import it into Fritzing and wrap it up. So this is my Documents Fritzing parts. That's my the personal parts folder. You grab these and you put that in there. And then when you open up Fritzing, it'll freak the hell out. So it's like, what's going on with all, you're just creating parts and deleting them, and there was this part and it's gone. That's okay. And it'll complain about this part because it's like it's missing because you just created it and then didn't removed it. But your new part appears. Wow. So you're pretty much done. There's a little bit of cleanup that has to be finished. So one thing that's true is if you try to connect A4 to 12 and you look in the schematic, it actually is going to VBAT because remember we moved the schematic pins down just a little bit. Hold on, rotate 180. It kind of it gets confused. It's like, wait, you moved, the pin was up here and now you moved it, it's down here, it doesn't like it. So you just have to do a little bit of cleanup. So you open up the edits, the part editor. And the first thing that you do is in the PCB, you see how you have those 4 mounting holes? Because I like having the mounting holes. Well, they're actually connected to 4 contacts, but those contacts aren't actually used. So you want to delete them because they're copper, but they're not connections. There's nothing you would connect to them. They're floating. So at the bottom, you will see all these P $1. Those are all the unused contacts. So you just delete them. Next, this actually isn't plugged into the breadboard, which is a little annoying. I like it when it plugs into the breadboard because then you can, if you do this, I just tied 2 and 3 together. It's not actually tied together because it's, according to Fritzing, this is floating above the breadboard. It's not plugged in. And there's pros and cons to making it pluggable, but I think a lot of people are going to be using this in a breadboard. They expect it to work in a breadboard. So under connectors, set all pins to male connections. And give it a second, and it will flip all them over. And then I'm going to save this part. Yeah, I know. And here's the funny part. You have to look again because it created a second part for you. And this time, see, there's these blue dots. And then when you snap it into the breadboard, all these green connections highlight. That's because they're connected together. Now, this breadboard wire from 2 to 3 is represented here. I mean, it's the wrong pins because, again, we have to fix it. But it does think of that as an electrical connection rather than oh, the part is just floating above the breadboard. Because now it's actually plugged into the breadboard. So this is a common thing that I think gets confusing. So we're not done editing, so let's keep editing. Okay, so we did the breadboard, and that's all good. We basically, all the parts are male. You can go through all of this connector list. I've never had that be wrong, but it's worth looking, just hey, is every pin labeled properly? Looks good so far. Actually, I want to rename 1 to be, 1 is the same as TX. So I'm going to name this 1TX. So I think that's, oh, sorry, RX. I know these connections have names, and then DFU is connected, so that's kind of nice. You can go through, and in this case, what's nice about that Fritzing generator is it'll tell you, hey, it'll automatically make the corresponding pin the connection. So you don't have to do any of that. So we do have to fix up the schematic because, again, it's confused about where the components are. The good news is that it actually, these parts on the right that I moved, if I click them, they highlight properly. And I don't know exactly why, but if you set the terminal point, which in this case is the point, it's basically the terminal point's wrong. Even though it knows what element it is, it's off by where the contact is. So just on the right side, you set all of them to east because that way it is connected from the endpoint. So I just go through and I set these all up. So you can click on east, and that will make it so that it resets where, because see, it's like 5, it thinks 5 is at 2.54, and then if I click east, it's like, oh no, really, it's at 5.08, so it realigns all of them, or whatever. And then on the other side, I do these, and I put them on the west contact, because this is the west contact. This way, when I connect a wire, it connects to the end of that wire. I mean, it's basically it's basically using SVG as a CAD system, which is weird. Like, it actually is selecting this SVG element, and then you tell it which part of the SVG is the contact point. Like, there's like intelligence, but it's a very funny sort of like taking advantage of the SVG file format and stuff to do a lot of this connection. Okay, so I think these are all done. Okay, so let me save that. PCB looks good. You can check all these pins, nice outline. The icon is automatically generated for you, and then you just have to set the metadata. So the metadata, I get rid of these underscores. And then the product page, you get the URL, put the URL here. And then I kind of add the description. And then I say Bluefruit module subpart drawing by Pig Hicks. And then I link to his website because his graphics are Creative Commons share alike attribution. This is a way to give attribution. And that's great. That's easy. And then under family, I put just the name of it. And then at a part number, I just put the Adafruit part number. I don't know what else you'd put in. And then you save it again. And that's pretty much it. So now when I go, I'll delete this. And then, yeah, now it has in the description here. In the subpart, it's got the right name. It's got a URL. It's like got links and stuff that probably work. It has the attribution down here. That's lovely. And then now if I link S-clock to 10, it should, yeah, it connects the correct pins together. So these are now connected. It knows, it doesn't have that issue where the wires were wrong. And that's it. So that's like an advanced feather. Oh, that's neat. When you draw in the schematic, it actually like has it here. It tells you like, hey, you're supposed to connect these. That's interesting. And then under PCB view, again, you have a PCB if you want to use it. I've never used it, but you can make like a feather wing, or you could have a PCB that uses this feather as a subpart. Hey, what's up? How's it going? The crow has no words to say.
No.
Okay, so that's pretty much it. That's how to do it. And then when you're done, export the part. And I put it in my Fritzing library. And this is the Bluefruit. And what's neat is, I realized this. I was like, oh, what if you wanted to edit the part after you're done? If you rename this to be a .zip, it's actually a zip file.
Yeah.
And all the SVGs are in it.
It's an old trick.
And he said, oh, well, because you open it up, and I was like, PK, oh wait, that's PK zip. So if you need to, if after you're done making the part, you're like, oh shoot, I forgot there's a silk screen error, or like I want to make a change, I want to add some text to the schematic. You can't make like anything deep and like complicated with components. You would do in the that part editor inside of Fritzing. But if you just want to make like a graphical change, like the PCB color changed, or adding a logo, that you can do by editing the SVG and then just shoving it back in. Because this is just the same breadboard file that we were editing earlier. So that's kind of handy. Elegant solution. So let's rename this FZPZ. So that's it. Any questions about Fritzing? I'll do a guide on how to use Fritzing at some point too.
Yeah, I think that'd be a good idea.
Yeah. Well, now I have like diagrams and stuff I can do.
Yeah, so then you've got, that's what they look like. That's the overhead.
Yeah.
And then that's the,
So that's that. Pretty good.
yeah. That's
Looks even prettier.
We got fritzing.
Yeah, it's got the little button, the crystal, and like, look at this lovely part. Really helps a lot. Like I like these a lot. Like a lot of fritzing files are like kind of basic like rectangles, which they're fine. But like, if you can generate
A
it,
lot of them look like they were like, you could do the same thing in PowerPoint, which defeats the purpose of using a tool like Fritzing, which has 3 views at least.
yeah,
And
I love it, and it's so easy. Like that, you know, it takes like 15, 20 minutes
it's
to
not,
make a part.
I mean, technology is the only industry that's like, oh, it's only like an easy 12-step process. But it's way better than the alternative.
It used to take us 4 hours
Yeah.
to make a part like this. Would take easily 4 or 5 hours because you'd have to draw.
Yeah, on average it was about
everything.
3 hours. And that's if you're cooking.
The really tough part, it's not even the schematic is not that hard, and the breadboard view is this is difficult. But like if you're an artist, but creating the PCB SVG is really aggravating. It's not hard if you know how to do it, but like you have to group the parts in like subgroups in the XML. That like the XML has to be like perfectly formatted. So like one time this generated a file that the SVG was not exactly perfectly formatted. There was like a part sub element that was misnamed, and like Fritzing just like exploded all over the place. So that took us like 2 hours to be like, why? But when we figured out, we're like, oh, okay, it's not too bad.
Yeah. So anyways, if y'all want to continue to support our efforts and all this stuff, we have talented people. We pay them money.
Yeah.
So buy an electronic kit.
Yeah, Phil B spent 3 weeks on this to get it into this shape.
Yeah.
3 weeks. So if you think about how much it costs for an engineer to do work, like it pays off, but it's like that's
Yeah.
And then we give these away.
Yeah, and the thing about like Phil B and Tony and Pedro and Kevin, they're more than engineers. They're actually artists. This is why we all seem to find each other.
Yeah.
And so there is an artistic element that they bring in, which is this looks great, it works great, and the hardware that goes along with it does all of those things. And then people use it for their own art. Mm-hmm. So it's
yeah, Phil B spent like a lot of time getting all the silk screen, like getting the silk screen and rotated silk screen to look right.
The resistors are perfect too.
He redrew all the resistors, and
the resistors are really nice.
He drew like the LEDs so that they're the color. So like, you know, the blue LED is kind of tinted blue and the red one's tinted red. And like it automatically detects, because, you know, I name the component and then I have the color be red, yellow, green, blue. So he automatically detects that. I mean, these are kind of tuned for the Adafruit parts, but still.
Yeah.
But yeah, it's like really lovely. And it
and I
even
guess
has a little Adafruit logo. And this is, it's just like hand entered in. Like he kind of had an exception to make that so it's not rastered. Because usually it's like Gerber rastered, where it's like it's a drawing like that on a PCB is like little rectangles.
Yeah.
And he actually took all those out and he replaced it so it wouldn't be too big.
For y'all who are watching this on Twitch especially, you know, you play video games and you collect a bunch of things, and then you take the quest and you have to put a bunch of things in order. You have to kind of solve the puzzle, and then there's a boss level and all that, and then it's over. Well, here's the cool thing to think about. You can do all those same things. All the parts of your brain get activated in the same way. However, you can send off the file. They'll send you a physical thing. You can create a business. You can create art. You can do all these things. I watch how you play video games, and I watch how you do engineering. And what's neat is, like, you send off the files, and then they arrive, and then eventually we ship them to customers, and people do cool projects with it. Mm-hmm. I think it's the one piece that's missing from video games, where when you're finished, you're not, maybe the closest thing
you're
is
like an achievement, but that's like it's not physical.
The closest thing, I think, like Noah and Pedro, I'm a little jealous sometimes because they can send their files off to something and then it prints it out. You can spend a lot of time and then you get a physical representation, and then you can carry this thing, much like I would carry a little crow around, about like, this is a thing that I spent a lot of time on and made. Like a video game, or even binge watching a TV series, you don't get an Iron Throne watching all the Game of Thrones.
Well, you have to go and buy it, but it's not like it's just something you made anyways. You could have bought it.
You can't really get an Iron Throne. You can't get like an Iron Throne.
Yeah, they're expensive. They're very big.
Yeah.
You have to have like concrete floors and stuff.
Yeah, I mean, at best you could learn a hobby and then make an Iron Throne. That'd be pretty cool.
But see, that's different than.
But it's different. So that's, I think, the part that's missing. And I think that's why Fritzing, in particular, is kind of interesting, because much like Arduino, like these are a bunch of artists that got involved. not exactly engineers.
Yeah, we
Arduino was
like a
not-
mix.
Yeah, Arduino was not an engineering collective. It was an educator collective.
Yeah.
And I think Fritzing and processing and Arduino have, like, that's the DNA.
Yeah. No, it's cool. It's working out. And what's funny is I was thinking there was a competitor to Fritzing. There was an online one, and was it CircuitSci? Yeah, was it?
Upverter?
No. It was one.
Updog?
It was Updog.
I love that joke. 'Cause you know the joke when someone says, "Oh, we use Updog,"
But you
and
have to
someone
do it
says,
to-
"What's Updog?"
You do it to a journalist or
I
something.
know.
Um,
That's funny.
it's for like journalists covering millennials. There was
tell
some
them that
other
everyone's an Updog.
company that was making, and it was a graphical thing like this. But the problem is, of course, you have to generate all the files.
Yeah.
And Fritzing, maybe an online version would be better. I think now they have an app version. But what's challenging is that even if you have an online version, you have to create so many parts to make it worthwhile. And there's like thousands of Fritzing parts.
Yeah.
And even
well-
if they're not beautiful, there's a lot.
Yeah, one of the challenges with all these online services is they say, upload to the server, but it's a keeper.
Well, until it's a deleter.
And then it's a deleter, and it's a beautiful journey, sunsetter.
Incredible.
And
journey,
one
yeah.
of the things is, I think people are getting a little fatigued about, like, okay, I'm going to use this online schematic thing, and I put up my files, and then, like, it all goes away. And I feel like Fritzing for us is a safe bet because we have graphics that we'll use for our tutorials, no matter
Yeah,
what.
this isn't. I mean, like, what's funny is, of course, like, oh, it's for the customers. Oh, yeah, kind of, but not really. It's actually for us. Like, it's for the people
We
who
have
are
to make
in house.
Yeah, this is
Do
a great
make
documentation
documentation.
tool. Yeah.
Yeah, because this way you don't have to have. Another thing is sometimes when you're documenting, you have wiring mistakes, which just happens because you build it, but then you rebuild it. When you rebuild it, you have a wiring mistake and you don't catch it. With Fritzing, you just drag the wire over rather than like, oh, you have to rephoto the whole thing or Photoshop it. It can be a lot easier to diagram it with Fritzing. So going forward, I'll be able to tell all the people who build tutorials and projects for us, okay, you have to use Fritzing. Just let me know which Adafruit parts you need Fritzified, and I'll do that.
Birds always look intent. It's like very.
Yeah, because they're looking
paying
for
attention.
bugs and worms to eat.
Yeah. Okay, so that's it. That's the Desk Gladiator. We'll be
Yay.
online tomorrow night, 7:30 p.m. Eastern Time, 8 p.m. Eastern Time.
Uh-huh.
It's show and tell. It's Ask an Engineer.
This was Bluefruit, Feather, Fritzing.
And crows.
Fantastic.
And crows.
And ravens or crows.
Crows and ravens.
Yeah. Corvidaes. Okay.
Okay,
All right, good night, everybody.
that's it, everybody. Crow Brand Electronics. If it's not Crow Brand, it's something else. It's a good slogan.